Okay, so pick all that apply. So I'm going to start going down. So x-axis symmetry, that's when we so x, y, that's when the y gets negated. So I'm going to plug that. So for this particular one right here, that would be negative y, and then everything else stays the same. Negative x plus 2x to the third. Is that exact? Does that algebraically go back to the original problem? Well, if I multiply off the negative 1, that becomes y equals x minus 2x to the third. That obviously is not the same one, so that one does not have a. Then if we do y, x, y, now then x gets negated. So for this particular one, for the first one, the y stays the same and the x gets negated. So it already has a minus from the problem, and then negative x plus 2 and then a negative x all cubed. Let's see if that goes. So a negative times a negative is a positive, and 3 negatives on this one keeps the negative. So it could go back algebraically to that, which is not exactly the same. So that one does not have b. Origin is when you switch them both, where xy becomes negative x, negative y. Okay, so I'll plug that one in. So I got negative y, and then negative negative x, and then 2 times negative x cubed. Okay, so that's still negative y. 2 negatives on that x makes it a positive. 3 negatives on that x makes it a negative. I'm going to multiply by negative 1 to solve for y. And sure enough, origin made that one go back. That one is c. And then when you switch around the x for y, the xy one means you switch the orders. That's going to be yx. So on number 1, that's going to be x equals negative y plus 2y cubed. Well, there's no way that's the same. So number 1 was just c. Here's number 2. I'll just tell you that number 2 ended up to be just b, and I'll just do the one that actually does work. So number 2, you exchange the x's. So we got negative x all squared minus 3. And sure enough, 2 negatives turn it back to positive, and it's the same thing. Now number 3 and 4, none of them worked on 3 and 4. Here when you put a negative x in there, it puts that one back to positive, but it leaves that one negative, so those two are always going to be different. So that means x isn't going to work, y isn't going to work, and then origin is not going to work. And when you switch the order, if you have an x there and a y, those are not the same either. So none of these work. And then same problem here. Since that one's even and that one's odd, they're always going to be at odds to one another. So x and y axis are not going to work. Therefore, origin won't work. And the symmetry, if you put x there, y and y. Now, if that doesn't make much sense, if that wasn't enough explanation, come let me tell you to you in person. We can try them all, but I thought maybe that would be a little bit quicker way.